Okay, looks like we're good to go. Screen share. So I just want to do a couple quick things and cover some of the links. This is the GitHub link. This is where our class syllabus lives. It's where, as I do work in my editor and I modify files at the end of every class, I will upload that file and the whole directory structure that I'm using to here. This is where you can find the slides that I'm working through as well. So today's slides, and I came to this page to I forgot. I think I forgot to post this in, but I'll do that right now. So today's slides are going to be 1 and 2 here, or 0, 1 and 0, 2, Introduction to Python and Python Basics, and I'll copy that in a second. So if I wanted to look at Python Basics when I start going through this slide, if you want to pull open the book, as it were, and go through it with me, which I highly recommend that you do, you'll just come here and do that. So let me just real quick, oops. Here is the link to the whole GitHub repository. And then here, let me include the link to this as well. I'm going to just include it as a link in the main message. I just edited the main message, but there it is as well when we go through that. So this is where you can kind of follow along with what I'm going to be going through if you want to kind of reference the material. We will have breakouts and the solutions will be posted. So if you don't want spoilers as we're looking through, just don't read too far ahead. If you do want spoilers, then I guess you could do that if you wanted, but kind of defeats the purpose. Okay. So some folks have asked about the syllabus. I'm here at the top level of this. This is the repository again, the main repository, and here's sort of the overview of the syllabus. And this is just right in the very top level of the repository. So I can come through here. This is the sort of synopsis for day 1 and a link to the recording. And this is for day 2. I do need to edit this to include introduction to Python as well, but that's also in the message that I posted. So you can come through here if you want to reference the videos or the material the next day or something. You can come into here and kind of look day by day and find the resources that we go through. Also, if you see anything that's missing or inaccurate, just let us know. We do our best to keep these accurate and updated, but sometimes things slip through the cracks. So do let us know if there's something that needs to be updated, and we'll get right on it. We've got a question here. For future links, you be sure to put the metadata for the links you post, like a short title, next to the link. Yes, I will do that. Let me actually edit that. I'll do that right now. This is the nice thing about Slack, is you can come in and edit your messages. You can delete messages and stuff too. It makes this really nice. And then this is cool. There we go. Hopefully that's better. All right, so that's this. One thing I covered yesterday, I just talked about documentation and PEP8 really quick. I wanted to kind of get into some other things, and I was running short on time, so I just wanted to kind of point at the links and say, like, hey, here's the documentation and PEP8. I do want to give these a quick glance. We'll give each of these a quick glance really quick. So this is docs.python .org for Python 3. Let me include this as well. There we go. So here's the documentation. This is, I mean, basically this whole thing is massive. This is the documentation and the more or less the specification of the whole language. So it's kind of huge. So navigating it can be a bit of an odd thing, but basically, let's see if we come to. I want to go to, I think, language reference. Yeah, so I'll come to language reference here. This is a good place to start. You can come to language reference, and then we've got all this. You don't have to go through all this. I certainly don't have it all committed to memory or anything. But let's just see. Let me see where the functions are. Oh, okay. They moved it in this version. So this is a slightly updated version and kind of moved the thing that I wanted to go to. But let's see. Python standard library. Oh, well, that really really kind of just throws a old monkey wrench in the old hula hoop there. Let's see if I go to 3.8. I might be able to find it in 3.8. Language reference. Okay. Apologies for that. I will find that link after class, but this is actually not a bad place to start and just kind of look through stuff. I would actually recommend just kind of perusing it. Don't expect to don't try to use this as necessarily learning materials to be your source of truth, as it were, but you can just kind of peruse through here and get a sense of how the documents or the docs are formatted and structured, and just kind of see what you can glean. But you don't have to dive too deeply into this. But it's good to just kind of start getting used to it. So, and I will find the part that I was trying to navigate to before. Will I increase the font size? Yeah, sure. Apologies. Hopefully that's better. You got to do it on every page here. Cool. So we'll go to PEP 8. So this is the PEP 8 style guide. I think this is kind of a funny thing. Maybe if you're really new to programming, the idea of a style guide or styling your code can be a little bit of a new idea. I know I kind of talked about this. So there's this thing that I've noticed about learning in general, where sometimes you have the sort of the things that a beginner will emphasize that are important, that a beginner sees as important in a given discipline, and then you'll have the things that an expert will perceive as important, right? So code stylization is something that you learn to appreciate sort of by necessity. It's a good thing to keep it in the back of your mind, at least. You don't have to be perfect at it, especially now. The important rule of thumb with whatever stylistic choice you make is be consistent. The single most important thing is be consistent. And if you deviate from your consistent way of doing things, have a good or obvious reason why you would do that. Be able to justify why you would deviate from that in that way. So this will give you I found it useful to just kind of read through here, just kind of go through and kind of look at random stuff, because it gives you ideas about how you can sort of standardize your code, make it prettier and easier to read and nicer to deal with. let's see. We got a question about the Zoom record button. I'm recording via OBS, which is a recording software. So I'm not recording through Zoom. So just in case anybody's wondering. Let's see. Memorize my entire Python reference by the end of the week. Yeah, okay, that's what I'm trying to say. No, that's definitely not what I'm trying to say. Okay, cool. Yeah, so I would give PEP 8 just kind of a look through and see what you can glean from it. I learn something every time I look through here. I kind of get a new idea or something. Here's some ways of formatting different data types and just kind of making your code nicer. So if it doesn't seem like an important thing to do, or it seems like, I just want to learn how it works, I don't want to worry about it like being nice. There's a reason that as you progress as a developer, as a programmer, you learn to appreciate this stuff because it makes everything easier. It makes everything you do easier. Well formatted, consistent code that uses like intuitive naming conventions, the good naming conventions for variables and functions and the various things that you have agency in naming in the language. Just makes dealing with that code just so much easier. So make it easy on yourself. Don't make it hard on yourself. Make it easy on yourself and do a little bit of formatting. Okay, cool. Let me, oops, lost that there. Let me grab this. Nope. And get my screen share for my editor here. Okay. Got a lot of people asking questions, which I really like. I wanted to kind of voice that. I appreciate the interactivity of this group. It's already feels very lively, which I like. So keep the questions coming in if you got them. Okay. All right. So yesterday we left off on comments, and I want to dive into this idea a little more. So comments, this is sort of another one of those sort of subtly useful things. Let me just start my file watcher here. Okay. Comments are another sort of subtly useful thing. You might think, okay, well, this is just something that I would use just in case I want to leave myself a note or something. But there are actually most of the time that I'm using a comment, I'm actually commenting out code. And it's code that I write to maybe do something to give me feedback or to test something out about my code. Often prints like this, which their purpose is to write output to the console. And I might want to like debug something or see what's happening at a very particular part in my code. I'll throw in a print there. And if I don't want to delete the print, but I don't want to run it anymore, I can just comment it out. That way, if I want to run it later, it's still there, and I just uncomment it, run it, and then comment it out when I'm done. So it's very common to use comments to turn parts of your code on and off like this. So you'll see my cursor is here, like in the middle of the line, and I can comment out this whole line by using a keyboard shortcut. Let me make sure. Yeah. The keyboard shortcut for me, I'm on Linux, and this should be the same on Windows. It's going to be Control and /. If you're on a Mac, it'll be Command and /. And that will hold true in that's held true in every programming environment I've ever used. It's a very universal shortcut. So that should be true in Replit, VS Code. That's how it is in Atom here. So control / to comment a line on and off. You can also use just a hash, just a regular hash. It doesn't do anything special. That's something about a text editor that might be a little bit different from like a word processor or some tool like that probably many of you are used to. In a text editor, as opposed to a word processor, well, let me put it like this. In a word processor, as opposed to a text editor, the text in a word processor has sort of metadata built around it, right? So if you read text that's bold, there's information about that text that tells that text to be bold and tells it how to format, right? And that's in the document with that text. In a text editor like this, like what you see is what you get. There's nothing in this document that I can't see right here, right? So all of the characters, all of the information in the document is right here, right? So I can just do Shift-3 to put in a hash mark anywhere I want. If I want to leave a line uncommented, but I want to leave a note at the end of the line, like, hey there, I want to say hi to myself in the future or something, I can just leave a comment at the end of the line like that. So this is how we can do a single line comment. We can also leave multi-line comments. So multi-line comments, there's two ways to do a multi-line comment. We can use two sets of triple quotes, and we can use triple single tick quotes or triple double tick quotes like this. So some people might look at this and think that maybe there's a slight difference between these, that one kind of does one thing and the other kind of does maybe something slightly different. There is zero difference between these. It's just two ways of doing the same thing. And it's kind of useful in this case. It'll become obvious later why it's kind of useful to have two ways of doing this. But there is no significance of one in one situation and the other in another situation. They are exactly the same kind of multi-line comment. So if I want to comment out multiple lines, I could say, this is a multi-line comment. And I could do the same thing in the other one as well, like this. Cool. And the interpreter, the program that executes my code here, the interpreter will just ignore this. So you might see these commented out little bars that I have here. So this is actually a combination. So a little trick that I invented when I very first learned to code. It was like the first significant thing that I did with a programming language and I actually still use it to this day. But they're little code block switches. I have a notes document that is, well, I have actually a couple, like maybe a dozen or a couple dozen notes documents strewn about my various computers. I'll tend to make a new notes document when it gets to around 10,000-ish lines of code, just so it doesn't bog down my text editor when I open it up. But I'll take a notes document, and anytime I do something and I want to save it, I'll just throw it in one of these comment blocks and throw it in my notes document, and I can comment it out. And then let's say I've got a bunch of code in there, right? And I can use it sort of as an archive. And I was like, oh, I remember doing this sort of thing, a couple weeks ago, and I can look through it, and then I can uncomment it out and then run that notes document. And then it doesn't run all the rest of the random code in there. It just runs that one little bit of code. And then when I'm done with it, I comment it out again, and then it's back to just being in a comment. So you don't have to do things exactly like I do them, but I found that to be helpful. And I find these little comments like this to be helpful. And then just the reason that I have a big long line of hashes here is just that it makes a clear barrier between elements. So that's the reason that that's like that. Just a clear visual separation. And then the trick here is just I leave this note uncomment /comment to d/activate. So if I uncomment, it will activate. If I comment, it will, if I uncomment, it will deactivate the code. If I comment that line out, it will activate the code. So, and I'll just throw this. If anybody wants to use that and play around with it, I will throw it in Slack. Sweet, sweet keyboard shortcuts indeed. Yeah. Getting good at keyboard shortcuts is wonderful. It makes for some very pleasant programming. Okay, cool. That's comments. I think we're good on comments. Anybody got any questions about comments? Feel free to put them in. Let's just go through here. I'll just read through this. So the reasons for using comments is we can kind of write internal documentation, send a message to someone reading your code that very much includes yourself. Sometimes if you solve a problem in a way that you know is necessary, but maybe sort of counterintuitive, but you know it needs to stay that way, you might make a little comment like warning, do not change this part or whatever. You know, if you have part of your code that might seem a little unconventional, you can be like, hey, you know, there's a reason that it's that way, and then you know you can have an opportunity to justify why things are weird. But so you might pass a message to yourself or someone else. If you're coming from another language, there are certain other languages where commenting is the convention, like it's conventional and usual, and you're supposed to leave lots of comments. I've read a lot of C code and some C++ code, but mostly C code that, you know, you'll get 100 lines, a document with 100 lines of code in it, and 75 of the lines are comments, and another 10 are just empty lines, and then you know, you have like 20 lines of actual code. But the convention is in Python is to leave no comments if you can get away with it, which you usually can. Python is written to be a language that is very easy to pick up, and it makes some sacrifices in runtime to be very easy to learn and read and write, but those sacrifices aren't that severe, and they're definitely worth it in the maintainability and the ease of maintainability and the ease of producing code quickly and easily. So the Python is thought of as what we call a self-documenting language. So we think of Python code as being often the documentation for the code. It's meant to be, it's designed to be readable. It's designed so that when you read it, you know what it does, rather than a lot of C code, which might do stuff with sort of direct memory access stuff where it's not as readily obvious what's going on. So you kind of have to explain everything. So, okay. So exclude some snippet of your code from running. That's what I'm talking about with this, you know, turning on and off different parts of your code. Provide function documentation. We'll kind of talk tacitly about documentation standards later, but we won't get too much into that. Leave to-do statements in your code for later development. This is a good one, and this is sort of often, you know, especially while you're learning, you know, you might use comments to sort of take notes in line with your code, which I highly suggest that you let that be sort of your note-taking part of your note-taking process. You know, leave a comment here and there while you're learning. Also, to-do statements. sometimes it can be obvious how, like, you have a problem and you know how to solve it. And the challenge is, how do I take that solution that I know will work, or that I am pretty sure will work, and formalize it into a series of steps, and then implement those steps in code, right? So formalizing into steps, implementing in code. So a lot of times, if you're like, oh, I know, I got it, like I understand it right now and I got to write it down, just take a few comments, do your best to formalize those into sort of algorithmic steps. And then now you only have one job, which is to take those predefined steps and turn those into code, right? So you don't have to do all of those at once. You don't have to like invent the process as you're coding through, although sometimes you do that too, and that's also fine. But if something obvious comes to you and you want to write it down, you can take a few comments and come back and fill that out as you go. Okay, cool. Lots of uses for comments. Python constructs. So we'll get into some common data types, simple operators, and assignment operators. Let me just kind of look through real quick. We can, yeah, okay. So let's talk about a data type. So data types are essentially abstractions for us to deal with different types of information, right? So if I have the number 92, that's different than the set of characters 9 and 2, right? So what I have here, Python would consider an integer on line 9. I have the integer 92. And here I actually have what we call a string, which is contains the characters 9 and 2. So integers are a numeric data type. They're a number, right? This is just a number. I can do math with it. I can add numbers to it. I can subtract with it. I can do all the mathematical operations. I can use it wherever I would use a number. Strings are the data type used for dealing with text, right? So if I want to deal with something like the the number is 92, right? I've got to be able to represent that number as text. But this is not a number. This 92 here is not a number. It's the characters 9 and 2 as characters, right? So this is a good example of why we have different data types. Sometimes I might want to deal with text. I need a data type that has, that I can communicate to Python. No, I'm trying to deal with the characters. I'm trying to deal with this text as text. And then sometimes I want to do math and I want to deal with the numbers as numbers, not characters, right? So we have different data types. So this says a data type can be thought of as a form in which a piece of data can exist. Yeah. So these are the numeric types. We have integers, which are floating point numbers, and Booleans. And if a floating point number, I mean, some of you I imagine probably have already know what a floating point number is. But if that term is scary, it's what you're used to calling a decimal place number. That's all. It's just a number with a decimal value. That's literally all it is. In computer science, we deal with numbers of many different bases. So if we called it a decimal point number, that would be a little misleading, because sometimes we deal with numbers that are not, sometimes we deal with numeric values in a non-base 10 orientation, right? Sometimes we're dealing with numbers in hexadecimal, which is really just a sort of an easier way to express binary digits. Sometimes we're dealing with binary directly, although much less commonly. And then, just being nerds, sometimes it's just fun to count in base 6 because it's objectively the best counting base system. Look it up for yourself. So being that we sometimes want to leave ourselves open to thinking about numbers as potentially being in other bases, although, Python integers and floats, when we deal with numbers, they're always going to be in base 10. The assumption that is that they'll always be in base 10, so you don't have to worry about like learning a different counting base just yet. So being that we want to think about numbers as potentially being in other bases other than base 10, calling a number with a fractional point value a decimal number is a little misleading because decimal means base 10. So the generic term for that that could be applied to any base is a floating point. And what it means is that the point, the dot, can move. It can float to a different position in the number, right? So, and that has to do with how the number is stored and dealt with on the machine level, right? So we have the characters of the number, and then we have a position for that point, for that dot, and that position has to have information on its own. So those are the two types that we would think of as numeric types. Those are the two data types that we think of as numbers. And there is a distinction in Python. We do make a distinction between integers, which are positive or negative whole number values, and floating point numbers, which are positive or negative, quote unquote, decimal point values, or any number with a fractional component, essentially. So we do make a distinction between those types, but Python's typing system makes our lives pretty easy, because if I want to write a mathematical expression between that utilizes an integer and a float, it's pretty easy to just combine them. You just combine them in the way that you normally would, and you don't really have to think about it. So in most cases, integers and floats are interchangeable, and they're always compatible with each other when we're performing operations, numeric operations, just which are mathematical operations. We can always combine integers and floats, and that's not true in every language, but it is true in Python. Okay. There's another data type that is considered technically a numeric type, and that's a Boolean, what we call a Boolean type. Now, that might sound like a potentially, I worry that could sound like a really dense concept, or like this, weird mathematical idea. So Boolean values are true and false. That's it. True and false. These are the two possible Boolean values. So, every possible numeric value, obviously I don't have time to type out here, because that's, negative infinity to positive infinity and probably a few other infinities in there. But Boolean values, there's just two values. There's two possible states to a Boolean data type, and it's just true or false. And so a Boolean is a simple idea. It's a simple type, just two possible states. But it comes up in a lot of places. And as we work through learning this, it's going to come up and be kind of a central idea in a lot of areas. So it'll come up a lot, and there will be some times when maybe something will be a Boolean, but it may not at first look like a Boolean to you, So we'll kind of get into that. You'll see what I mean. But at the end of the day, rest assured, it's just those two states that comprise Boolean values. Okay, cool. I already showed you the print function. I'll just do this. And actually, why don't I do this? I'll call this an int. Why don't I make a float as well? We'll make a float. We'll say 4.379. That's going to be a float. This is a string. And these are our Booleans. Bool is sort of the short hand for that. Okay. So I already showed you. Oh, we'll kind of I'll come back around to the type function. Okay, no, we'll do it now. So there's this idea of functions, and this is an idea that we are going to be kind of continually expanding on. But this is sort of just our first touchstone on it right now. So to be clear, I'm not going to explain everything there is to know about functions right now. So, we'll kind of get there piece by piece. So a function is a way of taking some predefined group of code, some predefined procedure that may have several steps, may have many steps, may have complexity, and it allows you to write that process once and then reuse it in various other places in your code. So Python has a lot of functions that are built into Python that we don't have to write, but later, towards maybe the end of this week or the beginning of next week, we're going to start writing our own functions. We will be utilizing functions that are built into Python, functions that other people write, functions that we bring in from other libraries, and our own functions all together inside our own functions to write code. So the first function I'm going to teach you is print. So anytime you're learning a new function, and print is kind of a weird exception to this rule, but in general, IPO. There's this little acronym, IPO, input, process, output, right? So sometimes, especially with a function that we're not writing, process doesn't really matter. So really the important ones are input and output. In the case of print does something that you could say by analogy is an output. It makes something visible on the terminal, and it's sure, you'd look at that and you'd be like, well, that sure looks like an output to me. I'm seeing the result. I'm seeing the output. So how is it not an output? When I say output, I actually mean something very specific, and we'll kind of develop that as we go. So we'll delete that for now. So what we're concerned about with print is what's its input. And I'm giving you this little schema, input, process, output, because every time you learn a new function or you're building a function, you kind of want to ask those questions. In certain cases, one or another or a couple of those input, process, or output may not be relevant in every case, right? Process and output aren't really relevant to print, but input is. So we want to give an input to print, and the way we do that is we give the input inside of the parentheses here. So the way we would invoke the print function is we'll type print, then parentheses, The parentheses are necessary. We can't omit them. I can't just leave them off because I don't like the way they look and then pass in whatever here, right? I have to put the parentheses on. So the parentheses are important. And then everything inside the parentheses is considered the input to that function. When we invoke a function, the word, there's a more formal word that we use to talk about the inputs into that function, which is an argument, right? So if I say hello, so I have this string value, HELLO, which is the word hello. And this string is an argument to the print function. I'm providing the argument hello to the print function. And now what print is going to do when I run my code is, you can see it's going to print out, or it's going to write that information to the console. So we can use this to start doing things. What kind of things? Let's do some math. Let's say I want to know what 3 times 8 is. So I can print anything that is a data type. Anything that expresses a value as a data type, I can print it off. So if I want to know the result of 3 times 8, I can write 3, and then this is a little star character. That's the asterisk. For me, it's shift 8 will give me the asterisk character. So 3 star 8 is 3 times 8. And that's going to give me the product of multiplying 3 times 8, which is 24. So if I print that out, notice I did not write 24 anywhere. I'm not printing 24 like this. I'm multiplying the numeric value 3 by the numeric value 8, and it gives me 24, right? Cool. So I want to show another function, which is the type function. And here's what I recommend. As you're learning, you're going to get stuck. You're going to get confused. Things are going to happen that you don't expect. And then once you become proficient as a programmer, those things will keep happening and you will be used to them. They're not going to stop happening. They will probably start happening with less frequency, but they will, I guarantee you, I promise you, those things will always happen. However, what you get good at is not preventing confusing or odd situations that you don't fully understand. What you get good at is figuring out why your code is doing something you didn't expect it to do. And that's debugging, basically. So you write some code, it doesn't do what you wanted it to do. You have to learn how to go in and ask, why didn't it do what I wanted it to do? So your 2 frontline best tools are print and type. And those are the first 2 functions I'm teaching you because they are literally that useful. You will use them all the time for the rest of your Python career, print and type. Okay, so print and type. So type is a function. It takes a single argument. The type of its argument is any type, and it simply just returns the type of that argument, and it returns the type in this funny little text here with the angle brackets, and it says class int. And when you see class, you can read class as type if that helps. But sometimes another word for type is class. There's a slight difference between a type and a class, but that's a topic for another time. So this says this is class integer. If I say 3.14, yeah. See, that's going to be a class float. If I throw some quotes around it, it's going to be a class string. If I do true, that's going to be a bool. False, That's going to be a bool, etc. So you can use the type function to kind of help give you the sense of what a given type is. So in all the examples that I've given thus far, it's not that useful because we're dealing with the literal data, right? So when it becomes more useful is when you have a function call that returns a value, or an expression whose value you're not sure exactly what value it expresses or what the type of the expression yields, or you have a variable that is pointing to a given value, and since you can't see that value, all you can see is the variable name. Maybe the type changes in a way you didn't expect, so you can use type to tell what it is. You know, it's not that amazing if I put in 5 into type. Well, it's, you know, I know because I just put in 5 that it's an integer, right? But if you ever need to use that, you can use type and print and type together like this. One thing I want to point out, if you try to use type on its own, I'm going to run my code and nothing happened. So run it again and nothing happened. So this code is executing. It is producing the type of 5. It's just that it goes, it happens. It just doesn't, we're not telling our code to do anything with it. So presumably I want to see what it is. So I want to print it out to the console. So I'll use print. So when we access the type, we have to put type inside of print. Type, let's do the input process output for type, right? So IPO for type. Let's do this. Type. The input is, oops, anything. You can give it anything of any type. The process, I don't really care about the process here. I do care about the, why is it doing that? Sorry. I do care about the output. So type does have an output. It outputs, well, if I wanted to know the type of type, I could pass type to type like this. So it outputs class type. That's what it outputs. Outputs a class type object that describes the type of the object passed. Okay. So if that doesn't quite make sense, you know, just use your intuition. I think it's obvious how this works. You know, you give it a thing and it tells you the type of that thing, you know. But this is sort of how I would formally express that. So again, I would encourage you, as I introduce new functions, as you learn new functions, I'll try to remember to kind of do this input process output thing. But if I gloss over something, or as you encounter a new function, at some point go over and, you know, say, okay, so for type, the input process output is, and then just take kind of notes on that. And you can see these are kind of rough notes. They're not highly precise. There's a little bit of formality to it, but just kind of give yourself a sense, okay, this is what I need to give it as an argument for its inputs, and then this is what I can expect it to give me back when I run it. Cool. Usually, for most functions, you don't really care about the process, but I keep it in there because IPO sounds cool, and sometimes you do care about the process. So it's just kind of like there for emergencies. Okay. So let's look over some operators. Excuse me. Yeah, let's look at some operators. So an operator is a built-in, operators are built into Python, and they perform some operations. So an example of an operator is the plus operator. 3 plus 7 is going to be 10, right? So if I want to know what 3 plus 7 is, I'll leave it to you. How would I complete this code to tell me what 3 plus 7 is? Got a name error using type. Interesting. Maybe VS Code. Are you using the when you're running your code, are you clicking the little green play button? Can I paste it in my code snippet? Yes, I will paste it in. Okay, so to be clear, I'm taking some questions right now, but there's a question on the table. The question on the table is, and I want you all to treat this as a little mini breakout. What can I do with this code, 3 plus 7, to make the result visible? How would I see what 3 plus 7 is equal to? I know it's equal to 10, but what would I do? So go ahead and write your code and then put it in Slack. Run it without debug. Okay. So in my experience, if you click the little green play button, that uses VS Code's built-in version of Python. From my experience, that's usually a version of Python that's in the 2s. It's 2 dot something, probably 2.7. Well, yeah, it's definitely going to be 2.7. We're using Python 3. So what I would recommend is using the terminal directly rather than hitting that play button, and executing your code with something like IPython and then the name of the file directly, and that'll give you a different outcome. But we can talk about like environment debugging stuff later. Okay, cool. Yep. So everybody's onto this one. So this is just print 3 plus 7 like this. Type 3 plus 7 into the terminal. 3 plus 7. So if I type 3 plus 7 directly into a regular terminal, and this is a regular Linux terminal, bash terminal like you'd see on Linux or Mac, I'm going to get an error. But if I start an IPython shell, then I can write those directly in there. So yes, that would be another way to do it if you're using the shell. Sorry to be pedantic, but you know, does spacing matter at all, or is that just a style thing? In this case, it's a style thing. Often I like to leave a lot of space between things, just spread things out, make it easy on the eyes. But you could do this if you wanted to. That will work exactly the same. There are other aspects of Python where white space, which is the invisible characters, new lines, tabs, and spaces, the space characters, those are syntactically significant in certain other areas. But on a single line, if I'm just putting in spaces like this between an operator and its operands, it's just a stylistic thing. Cool. Okay. Conda is broke. Okay, yeah. It can take a little bit of setup to get Conda up and running if it's your first time, but yeah, you got plenty of time to troubleshoot that. Could I please explain the terminal? I mean, how it's used, etc. I thought it just reflects the output of the code unless there is an input. Let's see. I don't want to get too off the rails. you know what? I'm going to do it. We'll dive into the terminal. Okay. I'm not going to go too far into this. Learning to use your terminal is sort of a thing all unto itself. Learning to like navigate your file system and directory structures, and see contents of directories and files, and create and delete directories and files. Those are all sort of day-to-day things that you'll want to learn eventually with a terminal. But basically, so this is my terminal. I'll just kind of pull this up. This is, even though this is inside of Atom, it makes it look like it's a part of my text editor, and you'll have something very similar to this on VS Code. By very similar, I mean exactly the same, except maybe a little bit different because you'll be using a different operating system. So it makes it look like it's part of your editor, right? We're used to seeing a program, and the program might have little different parts of it, and all of those different parts of the program are parts of the program. So it's kind of funny. This is an interface to my entire computer. The entire machine can be utilized, and I don't know, I can do whatever I want from this terminal. If I wanted to start my web browser, or if I wanted to close all the windows of my web browser, let's see, here's a good one, htop. I could see all the running processes. You know, if you ever really want to scare somebody or make them think you're smart, just type in htop and like really stroke your chin and act like it makes sense to you. You know, this is a good one, but this actually can be really useful. You know, I can see I'm using what is this? It looks like OBS is using 93% of my CPU for some reason. It's not surprising. So there's a variety of commands, and there's a variety of programs and tools that you'll learn how to use. And to be clear, I'm not trying to teach you htop right now. I'm not trying to teach you everything there is to know about the command line, because we can make a whole 5-week course just on that. But yeah, it's a tool that you'll grow in familiarity with in time, I would say. But in essence, it's a textual interface to your whole computer rather than a graphical interface. So that's the role that it plays. Cool. Yeah, cool. If you want me to talk more about it, you can ask a question after class. All right. So we're about midway through. I want to have a short break. We've got a bit to go through, so we'll just have a 3-minute break today. Let's reconvene at 6 minutes after the hour. If you're still around and you want to ask a question, feel free. Just put it in the in Slack there. Okay, another question. Any difference in selecting one of these interpreters in VS Code at this point? Deep learning, I don't know the difference between those two interpreters, but I I do everything I can through my terminal. So yeah, I'm not sure what that is. I would encourage you to just not worry about those sort of extra features and just execute your code directly through the terminal. So IPython 3, and then just find the document that you want to execute. For me, it's going to be in this directory relative to where I'm at, and then that'll execute your document. So IPython 3, and then the path to the document that you want to execute. That's how I would actually recommend you all running your code if you're using a local environment. If you have any questions about that stuff, feel free to DM me. If there's interest in this, if people are still having questions, maybe mid or late next week, and there's interest, I'll do a study hall on environment setup stuff. And we'll do a whole like setup VS Code workshop as best we can. You can show up for that. If you're finding VS Code challenging or frustrating, or it's not working right now, just use Replit. That is my recommendation for the moment. Okay. Interpreter looks for non-existent variable. Cool. Yeah. All right. Good. Let's get back into the material. It's good to go. Okay. Cool. Number types. So we covered the numeric types. We covered print and type. We even talked about strings and bools. Okay. This is another little breakout here. Something I forgot to mention regarding breakouts. What I expect and what I want for breakouts, I want you to work in a full environment, a full REPL, read, evaluate, print, loop environment, and I want you to run your code. So occasionally I'll do a breakout and I'll say, hey, what's the answer to this? And I'll get an answer where I can tell somebody just like wrote it out, and they think, the thought process is, okay, like I have to be the one to like write the code and just know that it's going to work. I think that's kind of a way of thinking that I would encourage you in for the most part to get away from, especially now. It's not that it's bad to like be able to validate code by eye. It's a skill that you will develop kind of naturally. I think it is best and most easily and most quickly developed by not trying to develop the ability to like just look at code and know it's correct, but by running your code in your environment constantly. If you do that, you will naturally develop a sense of what things work, what things don't work, and how to make things work, how to get things to do what you want them to do. So I encourage you, as we go through breakouts, to always run your code either in Replit or your local environment, whatever. Okay, cool. So let's get into, like I said, let's get into operators. So some operators. We'll get into some numeric operators. Pretty straightforward. We're just going to talk about how to do math, basically how to use Python as a calculator. So if I print, well, I could do 5 plus 7. I could do 5 minus 7. I could do 7 minus 5. I could do multiply 7 and 5, divide. Here's another kind of division. We'll talk about that. Here's another operator that's related to division. You can think about this as the remainder operator. Technically, its name is the modulo operator. We usually call it mod. I'll just usually call it the mod operator. The way I would say this is 7 mod 5. If that's confusing, just remember that the percent sign has nothing to do with percent. It is the remainder operator. So this says, what is the remainder of 7 over 5? And then I could also raise 7 to the 5th power. I could raise 2 to some power, 2 to the 10th, whatever. If I wanted to do the square root, some of you will know this trick. There's a better way that you should actually do this ultimately, but for now, this is a kind of a quick and easy way to remember how to do a square root. If you raise a number, so if I want to know, well, let's actually do a number that has a, 4 has a square root, but let's do another one. So 16, the square root of 16 is 4. So if I raise 16 to the power 1 over 2, and 2 is the root that I want the second root of 16. If I wanted the third root or the fourth root, I'd do something like that, but usually you just want to do a square root. So you can do that, and this will actually give us 4.0, which is a float. Cool. So let's just run this. There we get a whole bunch of numbers. That doesn't work. Okay. Anyways, yeah, you can see 5 plus 7 is 12. 5 minus 7 is -2, etc. Right? So I can use, for the most part, these operators I think are pretty intuitive. At least these first four. These first 4 operators are generally pretty intuitive. And I can use just any number with these. So now you know how to add, subtract, divide, and multiply. Let's kind of talk about these other ones. I'm thinking squaring and square rooting is kind of explained for now, but let's jump into these other ones. So division, things get a little weird because we have 3 operators that sort of fit into the division category. So one, let's call this standard division. This is the kind of division that you probably think it should be, right? This is sort of, I think, intuitive. If I do 10 over 3, so if this is, I'm trying to pick one that we know, right? 10 over 3 is going to be an irrational number. It's going to be 3.33333, right? So we know 3 does not divide evenly into 10. So when we use a single slash division, Python is going to give us a float. So notice both of the inputs into this division, both of the operands to this operator are integers, but it produces a float. And single slash division will always produce a float like this, regardless of whether the inputs are floats or not. If I wanted one of these to be a float, I could totally do that. To be clear, I didn't demonstrate this, but I could make make these any combination of integer and float, the floating point numbers. I could make it, the floating point numbers could be 0.0, or they could be have some more complicated fractional component. They could be positive or negative, floats or integers, whatever, and it'll work more or less like you think it will. So a floating point number, a single slash division will always give us a floating point number, regardless of the types of its inputs. And that's kind of convenient, right? Because I want to get as accurate to how many times 3 goes into 10 as possible, and it goes in 3.333, right? So what about how many times does 5 go into 10? Well, we know it goes in twice. So this is kind of a funny thing, and this might be something you have to tune your brain to a little bit. So even though 5 does evenly divide into 10, the result is 2.0. And this is important to note. There are, like I said, for the most part, floats and integers are interchangeable. Sometimes they're not. They are always compatible with these mathematical operations that we're talking about, but they're not. There's certain places in your code that require the use of an integer or require the use of a float, but not the other. So, yeah. Cool. So, even when we're using single slash division, even if the quotient can be expressed as an integer, in this case it's a whole number value. 2.0 is equal in value to 2. The floating point 2.0 and the integer 2 are equal in their value to each other. But this operation will always give us a float. And the reason for that is, in most cases, you want an expression to always yield the same type. You want it to always give you back the same data type, even if that output might make more sense as another data type. You still want to have it have a consistent output, consistent output type. Cool. So single slash division works a little differently. So if I do this, 5, so double slash division. Double slash division is called floor division, and it's called floor because it rounds the quotient down to the floor, right? So if you can think of like doing long division by hand, this is the kind of quotient that you would get from doing long division by hand. You get how many times does the divisor, or excuse me, the dividend go into the divisor. How many times does 5 go into 10? 5 goes into 10 twice, right? How many times does 3 go into 10? 3 goes into 10 3 times without going over, right? And without getting into a fractional component. So if I multiply 3 times 3, I get 9. If I try to add another 3, I get a number that's greater than 10. So I can only fit 3 complete 3s, 3 whole 3s into 10. Right? So this kind of operation can sometimes leave a remainder. So to get the remainder, we'll use the percent symbol, what is usually referred to as the percent symbol. In most programming languages, I think actually every programming language I've ever learned, it's always the modulo operator. It always gives us the remainder back. So this is a weird one, right? The percent symbol gives us the remainder. You can think about it as the remainder operator, but it's called the modulo operator, but we call it mod for short. So this is 10. The way I would say this is 10 mod 5. So 10 mod 5 has a remainder of 0. Now, it's easy to look at this and be like, oh, well, that's super weird. What a weird, quirky little thing. I guess I could use that if maybe someday I'll need to know the remainder of something. This might be a thing that you could look at and easily kind of set on a back burner. I'll tell you, you use modulo all the time. You're going to be using this a lot. It's kind of funny. I remember being surprised about that. And I've seen other people do this as well, where they kind of forget about modulo because it's kind of easy to forget about because you're like, well, I'm just never going to use that much. But really, truly, it does come up quite a lot. There are lots of situations where it's useful to know the remainder, and quite often we will use it to see, if the modulo of something returns, or if it evaluates to 0, then we know that number is divisible by the other number, right? So in this case, 10 mod 5 is 0. So that tells us if something mod something, if A mod B is 0, then B is a divisor of A. And if it's anything other than 0, then we know it's not a divisor, right? If we want to be able to tell if a number is even or odd, or a multiple of 3, an even or odd number is just a multiple or 2 or not, right? So if we want to know if something's even or odd, we can say, some number mod 2, and if that remainder is 0, then we know that it's an even number. FizzBuzz. Yep, that just kind of says it all. Well, maybe we'll do FizzBuzz at some point. Okay, cool. So those are your division operators, division and division adjacent operators. You've got single slash division, which will try to give you the most accurate answer. Something like 3.333, right? An irrational number could be calculated out to infinity. Computers are known as what's called finite precision machines. So there is a limit to the depth that they can calculate, and there are ways kind of around those limits. But for now, we're just going to accept those limits, and you just know that you don't have to worry about producing an irrational number and crashing your computer or something, because it'll stop after 15 or 16 digits. It'll stop. The number will just stop. So okay, cool. So I did see we have some activity in the thread, which is great. Let me kind of go through this. I'm seeing something about could we spend 2 or 3 minutes to discuss the difference between print and return? I know the general difference, but I've seen it's used interchangeably in challenges, and was wondering what the best practices are. I hope this makes sense. Still a Python newbie. So yes, this is a great question. It's a bit beyond the scope of what I really want to dive into in this particular class, because it gets into, I'm sure for a lot of folks here who don't know what functions are yet, or aren't comfortable with functions yet, there's some other things that we kind of have to predicate that on. If you are getting into the material and you're getting into functions, return specifies a value to be given as output. When I did the IPO thing, and I was like, output means something specific, that specific thing, when I'm using output in that case, basically means return. Okay, so if you're familiar with that idea, if you're getting into functions and you're like, what's the difference between print and return? So print says this function, or excuse me, gosh, let me rephrase that. Let me start over. Return says this function will have this, whatever that value is, as an output. And print says take whatever argument is passed to print and display it on the terminal, right? So return is unopinionated about what is displayed on the terminal. Return will not ever, on its own, display anything to a terminal. Print, likewise, will never tell a function to give back a value. It'll just display something, right? So one, you can think about the terminal as a chalkboard, and print just goes up and writes whatever you tell it to write down on the chalkboard, and return says this thing has this value, but it doesn't do anything with the chalkboard. So they are very different things. There are some times where that can be conflated in Learn, but yeah, I promise though that this is a concept. This very question is a concept that we will be diving into further in future lessons very shortly. So sorry to be brief on that one. Oh, cool. There's some examples here. Can I give a brief example? To give a brief example, I would have to... Okay, fine, I'll write a function. I'll give a brief example. I'm going to write a function. So we haven't gotten into functions yet, but we will soon. So this will all make sense shortly. So def add nums. Let's make a function that takes in two numbers, A and B. I'm not going to explain every facet of this. I want to, but I can't right now. And it'll return the sum of A plus B, right? So I have a function. I'm going to run my code. Nothing's going to happen. This is a definition of a function. It's a very simple function. This is a definition. It does not ask Python to run any code. It just says, hey, here's a process that you could run. And when you run this process, this is how that process is run. So let's invoke that function. Let's run it. Let's run that process. So now I've got to give it some arguments. Let's say I want to add 10 and 5. The product of, or the sum of that should be 15. So if I run it, great. Nothing happens still, right? So nothing has happened because I have asked I've defined a function. I've asked Python to run the function, and it did run the function. I promise you that it did, but we never saw any output because I didn't print anything anywhere. So print is the thing responsible for making there be output that you can see on the terminal. So if I wanted to see the output of this function returns a value. It gives back whatever A plus B is, right? So we have 10 gets plugged in for A, so this will be 10 plus something. And then we have 5 gets plugged in for B, so this will be 10 plus 5. So this expression evaluates to 15. And then once that expression evaluates to 15, it's completed evaluating, then that value, 15, gets returned. So this says, okay, whatever the values plugged in for A and B are is going to be the value given back when this function finishes executing. So if I say 10 and 5, those get plugged in for A and B, 15, return 15. This function with 10 and 5 passed to it as arguments returns 15. Print. So in order to see that, since this has the value 15, and I want to see it, I will print the function invocation. I will print the invocation, and I've got 15. And just to prove that this function gives me back the number 15, if I divide 15 by 3, I get 5, right? 5.0, okay? So we just learned about division, right? I can use division to divide two numbers. 3 is a number, and add nums 10 and 5 returns a number. So this is a number 2. This is the number 15. It doesn't look like the number 15, but it is. I promise that gives me back the value 15. So if I say 15 over 3, that gives me this number. So one pitfall of this, a lot of people will do this, and then we get an error, right? Because this function now no longer returns anything, right? So if I try to, maybe you're like, well, okay, that's great. Clark likes to return and then print the invocation, but I think that's kind of weird. This is a completely different situation now. This is nothing like what I was just looking at. And I recommend kind of setting things up in the way that I showed, and I promise I will get back into that. So if we look at this function prints the result, right? And if I don't do this divided by 3, this looks like it does the same thing, right? I pass it 10 and 5. It's going to display the result there, right, of 10 and 5. It looks like my function works. But as soon as I go try to treat this function like the value that it returns, I'm going to find out that it doesn't return anything. This function has no value that it returns. Now, if you don't specify a value to return, it will have an implicit quote-unquote return value of none. There's a data type called none, and it's when Python has to assign a value to something but doesn't know what value to assign. Then it will assign none. So if we look at this error, it's a type error, and it says unsupported operand types for division, right? And it doesn't know how to do division between the none type operator and an integer. So what it's saying is it doesn't know how to divide none over 3. And that's fair. I don't know how to divide none over 3 either. That's because it's like, what's the quotient of poodle over sandwich? It's not a math expression, right? Yeah, so that's essentially the difference between print and return. I'm gonna put a pin in that one. I promise you we will be revisiting this later. If you're still curious, if you can't stand not knowing, which I totally get, hang out after class, and we'll take this as a question for after class. Okay, cool. So I think we basically have gotten through the operators. I want to do a little breakout project. Let me touch on exponentiation and log here, and we'll write Pythagorean theorem. So I know I showed exponentiation, so if I wanted to do, I'll just touch on this real quick again. If I want to square something, it's something to the power of 2, right? So if I want to say 5 squared, the reason I'm doing this inside of a print is so that I can see it. They want to see the result. So 5 times itself twice is 25. 5 times 5 is 25. We know that. Okay. Like I said, if I want the square root of 5, I will raise 5 to the power of 1 over 2. And notice how I'm using parentheses here. We've got the parentheses for the print, obviously, right? And that defines the input boundary of the print. But parentheses actually have a few roles. They do kind of a number of different things in Python. It's kind of funny. Since they have a number of tasks that they are used for, they're what we call overloaded. And we use that term to talk about any piece of syntax that does multiple things. So parentheses are overloaded. They do a number of things. So one is that it delimits the input boundaries for a function, and another is that it delimits it delimits we can use them to control order of operations, right? So if you're familiar, if you were taught order of operations, I was taught PEMDAS, PEMDAS, as the mathematical order of operations. There's an order to which each operator is executed, and Python follows that order. And it better, because that's the order in which things need to be executed. So PEMDAS, if you don't remember, PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. Okay. So what that means is that when you have a mathematical expression, things inside parentheses are evaluated first. If there's an expression within parentheses that's part of an expression within parentheses, the innermost set of parentheses is evaluated first, inner to outer, right? So expressions in parentheses are evaluated first, then exponentiation happens, then multiplication, then division, then addition, then subtraction. So it happens in that order. I'm not sure. I mentioned that I'm dyslexic. I find looking at something and trying to like brain out the order of operations, I find it tedious, and for me it's kind of error prone. What I recommend, and I've noticed this with other people as well, so I'm not sure if it's a me thing. Maybe you find order of operations just second nature and totally intuitive. But what I do find much easier is, when I'm constructing my code, as I'm constructing it, I know which parts of it I want to run first. I generally kind of have that sense, right? So I know that this is 5 to the half, right? But the problem with writing things this way, 5 to the 1 over 2 is going to give me something else, right? That's going to give me 2.5. So I know, regardless of whether I've thought it through or not, in this case, I do need those parentheses because I know that I want this to be 5 to the 1/2, to the half the power, right? Another way of doing this, and you could do it this way, is to just put in 0.5, since 1 over 2 gives you the float value of 0.5 as well. But I always like to do 1/2 because I can kind of plug in a number here, do whatever, and get whatever root that I want. So in this case, you do need parentheses. That way the parentheses evaluate first. We get 1 over 2, which is 0.5, and then we raise 5 to that, right? Okay, so this is powers and roots. All right, cool. So let's have a breakout. So the breakout is going to be implement I have this written down because I don't I don't trust myself to remember how to spell Pythagorean. So implement the Pythagorean theorem. So for those of you who don't remember Pythagorean theorem, I'll give you the Wikipedia link. You can read about it. Here. And here, let me edit that. Put a heading on it. Okay, so this is a breakout link, implement Pythagorean theorem. So you can go ahead and read about it there. I would write out the formula for you in my text editor, but I would write it out in Python, and that would rob you of the opportunity to do it yourself. So if you don't remember Pythagorean theorem, it's a squared plus b squared equals c squared. So we want to solve for c squared. So the question is, if I have lengths for a and b, how would I solve for c? And I'll put in a prompt here. Okay, so there's a prompt. So you can get started on this. As a way of solving this, go to your, you can read through the little article if you want. Just the first paragraph. Don't read the whole article unless you want to later. But just that first little stanza is sufficient. And that picture, I think, helps as well. Yeah, so go to your replets, and you could write a function, or you could write just some code that would print out the solution to this particular problem. I do expect you to run your code, test it out. And I'm just going to put a couple minutes on the clock here. And once you arrive at a satisfactory solution, go ahead and just paste your code into Slack, into the class thread, and we'll go from there. Okay, so that's time. Go ahead and put on any finishing touches if you want, another 10 seconds or whatever to wrap up. If you don't have a solution, don't worry about it. Just copy paste in whatever you have and just throw that in there. Cool. So I chose this challenge because it utilizes just the basic things that we've talked about, right? Pythagorean theorem doesn't involve, any like summation or anything like that. It's just exponentiation and root. So I'll show a solution, my solution for this. Just real quick here, I'm just checking. I only see a few replies, so go ahead if you're go ahead and just put in whatever you've got at this point. Just put it in as is. If you really want to edit it or finish it, you can do that later. That's which I totally respect that. Cool. So what I'm going to do is there's a number of ways I could do this. I'll just kind of break it out nice and easy. We didn't even talk about variables yet. I'll talk about variables next. So if I wanted to print Pythagorean theorem, I could just take note that I'm printing C. So the value of C is going to be a squared things nice and spaced out. A squared plus B squared. B squared, right? So my A value was, I forgot my own values that I posted. 6 and 18. Okay, so 6 squared plus 18 squared, right? And I've got to get, so this gives me C squared, and I'm solving for C. So what I want to do is I want to take whatever this whole thing gives me, this is C squared, and I want to get the square root of it. Like this, right? So I have this first term in parentheses 6 squared, the second term 18 squared, and then they both comprise this term right here, right? So this first term is comprised of these two terms here. And that gives me, well, whatever that gives me, and then I get the square root of that, and that will give me the length of C. Cool. I saw some people break it out into variables, so we could do A equals 6, and we'll just mesh right into talking about variables. B equals 18, and then we could say C equals that'll be this, and we could replace this with that and that with that, and then if I wanted to, I could just get, so this is going to be C squared. I could print C, and I could also print C squared. Oh, 360. It's kind of neat. All right. Or excuse me, C the square root of C, which is that. Okay, cool. So this is another way we could do it. I saw a couple people define a function. That's not how you spell hypotenuse. I don't really care. Hypotenuse will take in A and B, and will return. Is it? Oh, I'll return this with A, B. Okay, cool. So a few ways we could solve that. I chose this because there's a bit of a pitfall that I wanted to include. There's a bit of a curveball that I thought perhaps might get you. So I saw some people do this, where we had A squared plus B squared, plus C squared. Right. So this is kind of a funny thing, and I mean, this is a very fair mistake to make. It's fine, but I want to I chose this because this problem actually has a good, even though it uses simple operators, it'll help you get in the sense, like, kind of get a sense of how to start thinking, like, okay, I'm looking at this mathematical expression. How do I translate that into code, right? So quite often, math is flexible within the bounds of the formalizations and of the domains that it's being utilized in, and it's flexible really within the bounds of our own imagination. So Python is kind of more strict than that at times, right? So in this case, the Pythagorean theorem states that A squared plus B squared is equal to C squared. And what we want to do is, what solves Pythagorean's theorem is a squared plus b squared, and that gives us c squared. So in order to do that, we can capture that result in a variable. So I could call this c, let's call it c squared is equal to this, and then c is equal to c, the square root of c squared. So that's going to be c squared to the power of 1 over 2, like that. I forgot I commented that out. Okay, like that, right? So we can do it that way. Cool. So I'm using some variables in here. I'm using this a and b and c and these variables here. So there's this idea of variables. It's a fairly simple idea. I'm willing to wager that just from me using it, you can already kind of tell basically what it does. But basically, it's a way when we have parts of our code that express a value. And what I mean, you might think, well, what's a value? What's an expression? What does it mean to express a value? It means something that will evaluate to a data type. So if I look at this, Python will evaluate this code, and it will produce it'll produce a number. I think this will produce, if a and b are integers, it will produce an integer. It only turns into a float when we do the square root part, right? So regardless, it's just going to produce a number. And that's what I mean by it evaluates to, or it expresses a value, right? So we have a value being expressed. So let's say I'm a fancy lad, which, sure, why not? And I've got this big expression. This is a fairly meaty expression. I don't want to, every time I want to do Pythagorean's theorem, I don't want to have to like write, every time I want this value of, Pythagorean's theorem for this a and this b, I don't want to have to like write this all out from scratch again. So I want to capture this in a value like that. So this will allow me to capture the result of this whole thing, right? And it's the same thing for a and b, right? So if I want to capture, if I want to capture the value 6, so I can use it in multiple places, I can use it wherever I'm going to use a, I know that I'm going to plug in the value 6 wherever I use a. I can just say a equals 6, right? And I can just give it this variable. I can give it any name that isn't reserved by Python. There are a number of things that Python will allow you to call a variable that you shouldn't call a variable. All of the built-in function names you can actually overwrite accidentally. So this is kind of a pain in the butt, but you have to just remember, I could call something print if I wanted, and if I wanted to print, there's no function called print anymore. It's gone. Print is now a variable with the integer value 6, and I get an error because it's like an int object is not callable. So I can't invoke the print function because there is no print function. So it doesn't like ruin my install of Python. It just overwrites it for that one program. So if I run my code again, and I fix the problem, we'll call it A, and then I can do A. So I get my print function back. So you got to be careful. Don't name anything print. Don't name anything type. Anytime you learn a new function, don't use that name for anything else because you don't want to overwrite that function. And then there are a number of keywords that it won't let you use as well. Cool. So that's variables in a nutshell. We covered operators. We covered some data types. We covered variables. We even got a little bit into functions. We wrote Pythagorean theorem. So We're wrapping up. I'll wrap up shortly here, but I'm just going to take another minute. I want to do a brief reflection, kind of what we've talked about here. So basically, what we've gone over today is, and I tried to keep things basically constrained to working with numbers and talking about numeric values and operators. We can definitely get deeper into that, and we will next time. But I wanted to keep it kind of mostly constrained to numbers to give you kind of you have kind of a useful skill with Python now. You can now use Python as a calculator. It is just everything that we covered today. It's now the best calculator you've ever owned because you can write the steps down and you can change things around, and it's really great. So next time, between today and tomorrow, or from here on out, if you want to, if you have something that you want to throw in a calculator, some process that you want to calculate, you can break it out into variables. You can break out the different parts into variables and calculate step by step and print out things along the way. And it can be really, this is a very simple way of using Python, but it's also a really useful one, and it doesn't use that much tools. So you now know how to use the best calculator you've ever owned. Yeah, I'll wrap it up there, and we will pick up. Let's see. Homework's in the description here. I think I'll try to work these breakouts into the next lesson, but we'll just pick up from the beginning of the day 2 slides tomorrow. Cool. So I'll wrap up there. I release you. Have a good rest of your evening. Have a good night. If you want to stay on for questions, please feel free. Just give me 1 second and I'll stop the recording.